Throughout history, a handful of brilliant minds have fundamentally changed how we understand the universe. These giants of physics didn't just make discoveries, they revolutionized entire fields of science. Their work laid the foundation for modern technology, from smartphones to space travel. In this journey, we'll explore the lives and contributions of four extraordinary physicists: Isaac Newton, Albert Einstein, Richard Feynman, and Stephen Hawking. Each of them transformed our understanding of nature in profound and lasting ways. Isaac Newton, who lived from 1643 to 1727, was an English mathematician and physicist whose work fundamentally shaped modern science. Newton's greatest achievement was establishing the three laws of motion, which describe how objects move and respond to forces. His first law states that objects remain at rest or in uniform motion unless acted upon by a force. The second law connects force, mass, and acceleration. The third law famously states that for every action, there's an equal and opposite reaction. Beyond motion, Newton discovered the law of universal gravitation, proving that the same force that makes an apple fall from a tree also keeps planets orbiting the sun. Newton's genius extended far beyond mechanics and gravity. He co-developed calculus, a revolutionary mathematical tool that allows us to calculate rates of change and describe motion with precision. This mathematical framework became essential for all of physics and engineering. In optics, Newton made groundbreaking discoveries about light, proving that white light is actually composed of a spectrum of different colors. He demonstrated this using prisms in carefully designed experiments. The impact of Newton's work cannot be overstated. His framework of classical mechanics dominated physics for over 200 years and remains accurate for describing everyday motion and planetary orbits. Albert Einstein, born in 1879 and passing in 1955, is perhaps the most famous physicist in history. In 1905, he published his theory of special relativity, which shattered our understanding of space and time. Einstein showed that time and space are not absolute, they're relative and depend on the observer's motion. A few years later, he developed general relativity, an even more revolutionary theory that described gravity not as a force, but as the curvature of spacetime itself. According to Einstein, massive objects like stars and planets bend the fabric of space and time around them, and this curvature is what we experience as gravity. Einstein's most famous equation, E = mc squared, revealed a stunning truth. Energy and mass are interchangeable, they're two forms of the same thing. This formula became the foundation of nuclear physics and explains the enormous energy released in nuclear reactions. The equation tells us that even a tiny amount of mass contains an incredible amount of energy. Einstein received the Nobel Prize in Physics in 1921, though interestingly, it wasn't for relativity. He won it for explaining the photoelectric effect, showing that light behaves as particles called photons. This work was crucial in developing quantum theory and has practical applications in solar panels and digital cameras. Richard Feynman, who lived from 1918 to 1988, was an American theoretical physicist known for his brilliance and his ability to explain complex ideas simply. Feynman's major contribution was developing quantum electrodynamics, or QED, which describes how light and matter interact at the quantum level. This theory united quantum mechanics with Einstein's special relativity and explained electromagnetic interactions with unprecedented accuracy. To make these incredibly complex calculations manageable, Feynman invented what are now called Feynman diagrams, simple visual representations that show how particles interact, collide, and transform. These diagrams revolutionized how physicists approach particle physics calculations. In 1965, Feynman shared the Nobel Prize in Physics for his fundamental work in quantum electrodynamics. Beyond his research, Feynman became famous as a scientific communicator and educator. He had a unique gift for making the most abstract concepts accessible to everyone, from students to the general public. His lectures at Caltech became legendary and were published as books that continue to inspire physicists today. During World War II, Feynman was a key contributor to the Manhattan Project, the scientific effort that developed the atomic bomb. His work on theoretical physics during that project demonstrated his exceptional problem-solving abilities. Stephen Hawking, born in 1942 and passing in 2018, was a British theoretical physicist who transformed our understanding of the universe's most extreme objects. His greatest discovery was proving that black holes aren't completely black. They emit radiation, now called Hawking radiation. This was revolutionary because it showed that black holes can slowly lose mass and energy, eventually evaporating over incredibly long timescales. Working with mathematician Roger Penrose, Hawking also proved singularity theorems, which demonstrated that the universe began from a singularity, an infinitely dense point. This provided crucial mathematical support for the Big Bang theory. Hawking was a pioneer in cosmology, successfully bridging quantum mechanics and general relativity to understand the universe's origins and evolution. His book, A Brief History of Time, became an international bestseller, bringing complex ideas about cosmology, black holes, and the nature of time to millions of readers worldwide. Perhaps most inspiring was Hawking's personal story. Diagnosed with amyotrophic lateral sclerosis, or ALS, at age 21, doctors gave him only a few years to live. Despite becoming almost completely paralyzed, Hawking continued his groundbreaking research for over 5 decades, communicating through a speech-generating device and inspiring millions with his determination and brilliance. These 4 physicists each transformed our understanding of the universe in fundamental ways. Newton gave us classical mechanics and universal gravitation, explaining motion and forces that govern everything from falling objects to planetary orbits. Einstein revolutionized our concepts of space, time, and gravity with his theories of relativity, showing that the universe is far stranger than we imagined. Feynman developed quantum electrodynamics, revealing how light and matter interact at the smallest scales with incredible precision. And Hawking explored the cosmos's most extreme phenomena, black holes and the birth of the universe itself. Together, their discoveries form the foundation of modern physics and continue to shape scientific research today.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.